Unit 6, Lesson 4. Today the lesson is about tape and hanger diagrams. Our essential question for today's lesson is what are tape and hanger diagrams and what are they used for? So let's take a look at tape diagrams first. A tape diagram is a rectangular model resembling a long piece of tape in the shape of a rectangle split into algebraic pieces to show an equation. All right, so this is your very first lesson on equations. So far, we've learned about expressions. And by now, you should understand that expressions do not have equal signs. They have no equal signs. But equations, today's lesson, and the next number of lessons have equal signs. These equations have equal signs. That's the difference between an expression and an equation. So you can see on this very first example, there is an equal sign right in the center. Well, kind of in the center, right there. And we have two sides to the equation. Now that's important to learn that there are two sides. We have the left side, which is where the variable is, x, and then we have the right side, which just has the 7. Now that doesn't mean that the variable is always on the left. We'll have some examples with the variable on the right, so you can get used to it being on either side. All right, so let's take a look at this first tape diagram, and it's just saying that x plus 4 is exactly equal to 7. So this piece of tape has 1x, just like this does, 1x, and it has 4 units, and it has 4 units here. So this entire piece of tape from the very beginning to the very end is worth 7. Okay, so how do we solve this? Well, you can break this tape up. You can see that there are some constants, and if you combine these like terms, that would be 4. And you can also see that there is only one x. Okay, and the x is unknown. We do not know what the x's value is. So to do this, you would take 7, the entire piece of tape, and subtract 4 from it to find out what the leftover piece of tape is, and it is 3. Now that was an easy one. You probably knew the answer already, but that's how it works. And so the answer to this is x is 3. And that's how tape diagrams work. Now there's different variations, and so let's take a look at this next one. This next one, again, the piece or the variable is on the left side. You can see it's 3x, and then we have the equal sign, and then we have the other side, 9. And there are two sides to the equation. So this entire piece of tape, the equation's telling us that it's equal to 9. So from here all the way over to here is 9. And then down below, we have these x values, which we don't know what they are. So we have this value here, this one, and this one, and we don't know what any of them are. But they are all the same number because the variable is the same. So whatever this first x is going to be, that means that this x and this x have to be the same number. So if they're the exact same number and they all together equal 9, then you're going to take 9 and you're going to divide by 3. And when you do that, you get 3. And let's see if that works out. And it looks like it does. If they're all 3's, that's what the value of x is. So x is, again, 3. All right. Now we have one with distributive property. Now, we learned distributive property just a few lessons ago. And we want to take a look at how this one works. Let's start by painting up the equation. The left side, again, has the variable. It's an r inside the parentheses there. And then we have the equal sign. And then we have the other side, which is equal to 24. And that 24 is important. It's telling you what that piece of tape is valued at. So from here all the way over to here is 24. All right, inside that piece of tape, there are two r plus 3's. And you can see right here in the beginning, it says that there are two r plus 3's. Normally, you would go 2 times r and 2 times 3, which is 6. That would be the distributive property. And you could build that out right there to get that done. All right? But that's not what we're going to do. What we're going to do is we're going to take these boxes and we're going to split them up. Okay? So this is a plus r plus 3. That's a positive 3. So I'm going to put a line right here. And I put a line right here. Okay, now it says r plus 3 plus r plus 3 is equal to 24. So we're going to combine like terms. And to combine like terms, we're going to redraw this piece of tape. So I'm going to add another piece of tape right here. It's a shallow one. And there are 2 r's. I'll put those down on the left side, and then there are 2 3's. Okay, now I redistribute those, and now I can say, well, what's this value right here? It is a value of 6. And what is this value right here? We don't know. So let's go ahead and start. Let's take these 2 3's, which is a total of 6, off of 24. So let's shorten the tape. So that's 24 minus 6, and that's going to give us 18. So the rest of this value right here is worth 18. Okay? But what is 1 r worth? Well, r is the same number, and if it's all 18, that means you're going to take your 18, you're going to divide it by 2 because you have 2 variables, 2 r's. And when 18 divided by 2 is 9. So this r is 9, and this r is 9. And if you go 9 plus 3 is 12, and 9 plus 3 is 12, and 12 plus 12 is 24. So that's how you work with those distributive property problems. And now we have something different on the fourth one. You can see the variable is now on the right side, which should not be an issue for you. And the equal sign is still in the center, and it equals 50. Okay? It doesn't matter where that variable is, it's the side that you work on. So this entire piece of tape, again, is worth 50. So we're going to go from here all the way over to here. 50. All right, we see that we have a couple of different pieces of tape here. We have this one, which is exactly worth 8. And then we have all these U's here. And it looks like there are 6 U's. So let's go ahead and take care of the easy number first, the constant down here, and do 50 minus 8. And we get 42. So the rest of these U's are worth 42. Now how many U's are there? There are 6 of them. So we're going to divide 42 up into 6 pieces. And when we do that, we get 7. So that means U is equal to 7. Let's find out. So we have a 7, 7, 7, 7, 7, and 7. Well, if you add up all those 7's and the 8, you do get 50. All right, so that's how the tape diagrams work. And now it's your turn. I'm going to get you started on A. We'll work through it together. But if you can work ahead of me, that would be phenomenal. Okay, so you have pieces of it. We have 13, which is what the other side is worth. And then we have the equal sign here. And then we have the other side, 4k plus 9. So we'll paint that green. Okay, so this entire piece of tape is worth 13, and this, of course, is worth 9, and this part is unknown. We don't know what the 4k's are worth. Okay, so let's take 13 and subtract 9, and that's going to be 4. So these 4k's are worth 4. Well, how many k's are there? There are 4 of them, so we're going to divide this by 4, and we get 1. So k is 1. Does that work out? 1, 1, 1, and 1? It sure does. 13. Okay, it's time for you to try it on your own. Notice that the variable is on the left side this time. Pause the video, try it for yourself. Okay, I have it set up here. I saw that there is an equal sign and there are two sides to the equation. The entire piece of tape is 48. I have the small constant down here of 12, and then I have 6 t's. So we're going to take 48 and take off 12, and that's going to be 36. So the rest of this piece of tape is worth 36. Now there are 6 t's, so we're going to divide 36 by 6, and we get 6. So t is 6. If you write them all in and add them up with the 12, it is 48. All right, now we have a distributive property one, and we have an example up on top that how we did that one. We split the boxes up and made a new piece of tape. So use this one right here as your example. Pause the video now. All right, let's see how you did. Did you break up the main tape with the X and you split it away from the +9 and reorganize it with all the X's together and the 9's on the end? If you did, that's going to be helpful. So you have 27 total 9's here. And so we'll take 57 and subtract 27, and we're going to get 30. So the rest of this piece of tape is worth 30. Now there are 3 x's, so we'll divide this by 3, and we'll get 10. So that means that x is 10. If you put 10 in here and add 10 plus 9 3 times and add those numbers, the 19s all up, you'll get 57. All right, now it's a build your own. So we will do this one together, and then you'll do the next two on your own. Okay, so what you'll do here is you'll still paint things up. We have the equal sign, and then we have the number that it's all equal to is 18, and then we have the other side where the variable is. Now the variable's on the right side again, which should not bother you. Okay, so we're going to make our rectangle. You can make it as long as you like. About that long will be just fine. And inside the rectangle, you can see that there are 3 m's and there is the number 6. So we need to start with the very first box here. There's 1 m. Try to make them the same size. That's an m. And then we'll do the next box will be an m. And then the last portion here will be that 6. Okay, so we'll say that the whole entire tape is worth 18. This is obviously worth 6. And we're trying to find out what the leftover piece of tape is worth. So we'll take our entire piece of tape and we'll chop off this 6 here by subtracting 6 off, and we'll get 12. So we know that this portion is worth 12. Now there are 3 m's, so we're going to divide that 3 by, or sorry, divide that 12 by 3, and we'll get 4. So we know that m is 4. And if you read 4's right here, 4 plus 4 plus 4 plus 6 is 18. So that's how you build your own. It's your turn. Pause the video and build your own on E. Okay, we're back on the tape diagram for E, and the answer is C equals 8. So if you did not get 8, pause that video and take a look at this building your own piece of tape. Erase it up and make sure you get it right. If you're still a little confused, you can always rewind and go back and look at those things or ask questions. Your teacher would love to help you. Okay, so let's go ahead and take a look at F right here. Pause the video. Now this is distributive property, and if you need help, go look back at C, how it was built, or go look at the example that we did up above. Pause now. Okay, there was a lot of drawing on that one. So we have a long piece of tape, and there were actually 5 J plus 4s up there, and you can see them. I built 5 J plus 4s. I split my boxes j plus 4 into j and positive 4. I reorganized all my j's together on the left side, and I reorganized all my 4's on the right side. And then I went through solving with the tape diagram. So that's tape diagrams, and now we're going to flip our paper over and look at hanger diagrams. What is a hanger diagram? A hanger diagram, they show how equations are equal. All right, so we have 3 we-dos. Let's take a look at those, and then you're going to start your own. Okay, so hangers in your closet. If you had a hanger, sometimes when you hang clothes, they look like this. Okay, when your hanger looks like that in your closet, usually your pants or whatever slid down to one corner and now it's hanging from the corner. Well, that is not a balanced hanger. A balanced hanger would be in your closet, sitting like this, perfectly even like this, with your pants or whatever's hanging from it centered so the hanger is balanced. And that's what you're looking at right here. Those are some rough drawn hangers. But over here we have equal signs. So you can see that this little stick up here is kind of like the hook for the hanger. So that's where the equal sign is. Okay, so there are 2 sides to that hanger. So what are these 2 sides? Well, you can see on the left side we have 2 z's and 3 1's. So if we combined like terms, you've heard that one before, we have 2 z's and we have 3 1's, which is worth 3. That's what the left side of the hanger looks like. Now this hanger is balanced. It's balanced with exactly the other side. The other side says that it has 5 units. So on this side we put a 5. And the hanger says it's balanced because it says in math that it is balanced. It's equal. So it doesn't matter that one side looks longer than the other or they're the same length. That does not matter. It just means that this sign right here means that it is equal no matter what. Okay, so this sign means equal, and we have the 2 sides just like we did on the tape. We have what everything is equal to, and we also have the side with the variable. All right, so how do we go about doing hanger diagrams? Well, they're similar, and we'll learn how they kind of are very similar in a couple lessons from now. So let's take a look at the first one here. So in a hanger, if you take something off of one side, you have to take it off the other side. So if we're going to take off a 1 here, we need to take off 1 here to keep it balanced. That makes sense. Okay, and then we're going to do that again. To keep it balanced, we're going to do 2 for 2. And if we're going to do 3 for 3, we have to do it to both sides to keep it balanced. Now the last thing that we have left over here is we have 2 z's. And we have 2 1's. So just like we did on the tape hangers, we took our remaining number, which is a 2, right here. We had it up on top, if you remember, and then we took how many z's or how many variables we had underneath. So we put that underneath. And 2 divided by 2 is 1. Okay, so z is 1. And if you put a 1 here for that z and a 1 here, that would make sense. So 1 plus 1 plus 1 plus 1 plus 1 is equal to these 5 1's over here. So we know that we got it right. And that's how a hanger diagram works. So let's go ahead and try the next one. So let's build our equation off of what we see here. So we do know that it's equal because it's a hanger diagram. We know that there are 3 x's here. So we're going to write 3x. And we know that there are 2 units here, so that's our constant plus 2. On the other side, we have 3. So we take our 3 and we put 3 here. Now we're going to paint it up just so you guys know that there are 2 sides. There's your equal sign. Your equal sign is equal to 3, and your variable side has 3x plus 2. All right, so let's go ahead and start. Is there anything we can take off of the hanger and keep it balanced? Yes. This 1 for 1, another 1 for another 1. And now we have nothing else that is equal. So we have 3 x's and we have 1. So on this side, we only have 1 left over, so we're going to put a 1 here. And that 1 needs to be divided into 3 x's. So we're going to divide by 3. And 1 divided by 3, well, you just have the answer. It is 1/3. So each x is worth 1/3. Let's check to see if that's right. This x is 1/3, this x is 1/3, this x is 1/3, and then you have a 1 and a 1. All right, so 1/3 plus 1/3 plus 1/3 is 3/3, and 3/3 is 1, and that 1 plus this 1 plus this 1 is 3, so it matches up. Okay, one more we do, and then you're going to start doing them on your own. Remember, it is a hanger diagram, so this is equal. On the left side, we have how many variables? We have 5 of them. They're all the same. So we're going to combine them, 5x plus the 2 left over. And that's equal to 17 on the right side. Okay, we'll paint it up. Our variable happens to be on the left side. And our answer is on the right side. And we are dealing with an equal sign, which tells us that there are 2 sides to the equation. Okay, so let's go ahead and begin. This one's a little bit different. This has a 2 and this has a 17. So you might say there's nothing that matches. But we can handle this 17 by crossing it out, putting a 2 down here, and 17 minus 2 would be 15 left over. And this bar here is still worth 17. 15 plus 2 is 17. Now we can cross off the 2 and the 2, and we can see that this bar is worth 15, and these 5 x's are also worth 15. So we need to take our 15 and divide it up into 5 pieces to find out what each x is worth, and that is 3. X is 3. We can check it. 3 is all the way down, and the 2 equals 17. So it works out. All right, we've gotten to the spot where you're going to do it on your own. So go ahead and pause the video and try G now. Okay, we're back, and here is a solution for G. Did you paint it up? Did you highlight the equal sign? And did you cross off 3 at a time, because those were equal parts? And see that there is 2 y's left over, and those 2 y's are worth 4. So you take the 4, divide them into 2 pieces to find out what each y is worth, and y is 2. I checked my work, 2, 2, 1, 1, 1, and those equal 7. Okay, pause the video and try H now. Okay, we're back. I made my equation 7 equals 3x plus 1. There were 3 x's and a 1 on the right side. My variable's on the right side now. That doesn't matter. And I reorganized the 7 over here. I crossed it out. I put a 1 on the bottom and a 6 on top, which still equals 7. I crossed out the 1's, and I found out that my 3 x's are worth 6. So I have to take my 6 and divide it up into 3 pieces to find out that it is 2. So I replace my x's with 2, 2, 2, 2, plus the 1 is 7. And so I know my answer is correct. Okay, now it's time to build your own. I'll do one with you, and then you'll do the rest. So I would put the hanger right underneath the equal sign. Make your 2 little sticks. And on the left side, you can see that you have 1 in. You could use circles or boxes or whatever. And then you have 6. So you could do a 1, a 1, a 1. You could do 6 boxes of 1. But I like to have a little shorter work, so I have 6 there. On the right side, I have 13. Okay, I'll paint this all up. My variable's on the left side. My answer's on the right side, and my equal sign is right in the center. All right, let's go ahead and start. So we have 6 over here, no 6's over here, so I'm going to borrow from the 13 and create a 6. And 13 minus 6 gives me 7 left over. So now I can cross out my 6's, taking the 6's off. And now I have 7 left over, and I have only 1 in. Well, that one's pretty easy. if there's one n and there's 7 over there, you know the n is actually 7. But let's go ahead and do the math. Here's 7 split up into one thing, and that is 7. So n is 7. So if I put a 7 here, 7 plus 6 is 13, and that was what I was looking for. All right, we build one together. You saw how to do that, so go ahead and pause the video and build J now. Okay, here you have J. I got a little ugly on my hanger there. Hopefully you got it right. If not, go back and look at your work. Sorry about that. And ask your teacher or review the video again. All right, now I'm going to have you pause the video. You're going to do K and J, or sorry, K and L. Both of them. Pause the video now. Okay, here are both the answers for K and L. Look them over real carefully. Erase your work if it's not right. Ask some questions and make sure that you got the hangers down. All right, now it's time for the test readiness check. And as you've seen this before, these types of questions will actually be on your unit test, or on the state test, or on your FIABs, or other district assessments. So it's very important that you understand how these work and that you can do them on your own. So let's go ahead and take a look at M. They are UDOs, but since they're word problems, I want to help you get started on them. So let's take a look at M right now. M says, Yomi is collecting 3 identical baskets from her garden. Each basket contains R number of carrots and 5 Brussels sprouts. There are 36 items in total. Build a tape diagram to display her situation. Then explain your solution. Okay, so let's go ahead and use this piece of tape here. We're going to build it. Now, what is Yomi collecting? She's collecting 3 identical baskets. So I know that there's not a lot of room in these boxes to work. So over here, underneath the UDO sign, we're going to say 3 identical boxes. So we're going to put a 3 here, and inside those identical boxes are items. What kind of items? Well, it says that each basket contains R number of carrots. So we're going to put R. We don't know how many carrots are in the basket. Plus 5 Brussels sprouts. So we're going to plus 5. And together in these baskets, in total, all 3 baskets, there are a total of 36 items. So we're going to say equals 36. Now we know what this looks like already. We know that the variable is on the left side. We also know that everything is equal to 36 and it's split with an equal sign. Okay, so let's go ahead and use a tape diagram for this distributive property problem. Now, how many R plus 5s are there? There are 3 of them. So you need to split this up into 3 pieces. Try to do it as even as possible. It's R plus 5, an R plus 5, and an R plus 5. We also know that the entire piece of tape is worth what? 36. So we're going to go from here all the way over to here. Okay, and if we were to redo this one like we did up above, we would chop these. Oops, wrong chop. Right here. Okay, and we would distribute them or reorganize them, combine like terms. We have R plus R plus R plus 5 plus 5 plus 5. Okay, and so we know we're running out of room down here, but we know that 36, we're going to take off these 3 5s, which is 15. So 36 minus 15 is 21. And we know that 21 is what these 3 R's are worth. So we need to take 21 and divide it into 3 pieces. So 21 divided by 3 is 7. So every R is worth 7. What does the R stand for? The R stands for the number of carrots that are in a basket. There are 7. All right, so that's what Yomi did, and now we did build a tape diagram to display her situation, and now we need to explain the solution. So this is the solution right here. R equals 7. So what can we say about that? Well, we can say that the 7 stands for carrots. So Yomi has 7 carrots per basket. Or Yomi has 7 carrots in each basket. All right, we kind of did that one together pretty much. So this next one is a story about Punch, and this one's different. It is not distributed property. It's going to be more like the other ones that you did. Okay, so I'd like you to try it on your own in pencil. That way, if you make any mistakes, you can correct them. Let's read it together before you pause. Punch is giving 6 friends C movie tickets each. He is also giving away 12 bags of popcorn randomly. That's important. Not each friend is getting popcorn. It's a random gift. He is giving away 36 things in total. Build a tape diagram to display his situation, then explain your solution. So right over here, you need to build an equation that this story is talking about. You're going to have a right side, which what everything is totaled up to be, and you're going to have a left side where the variable is and all the things that you need. So go ahead and pause the video and try building that equation first, and then come back to see if your equation's right before you start your tape diagram. Pause now. All right, here's the answer. 6c plus 12 equals 36. That is the equation you are building. Okay, so now that you have the equation, if you have it wrong, maybe you misinterpreted the question, the problem here. It says Punch is giving 6 friends C movie tickets. Here's your variable C. We don't know how many movie tickets each friend is getting, so that's why we say there are 6 C movie tickets. And then he is giving away 12 bags. The 12 is a constant, it's by itself. And then he's giving a total of 36 things in total. So that is the correct equation. You're going to pause and build it in the tape diagram to come up with a solution, what C is. Pause now. Okay, we're back. Check out your tape diagram first. Did you have 6 C's in a row and the number 12? And did you make the entire piece of tape worth 36? From there, did you take off 12, the constant, and have 24, and take the 24 and divide it into 6 C's? So divide by 6 to get 4. And C is 4. So what's C stand for? It stands for how many movie tickets each friend is getting. Okay, so Punch is giving 4 movie tickets to each friend.